All right, so welcome to this video. Today we'll be looking at past paper exam questions, okay, in chemistry. And the topic that I've focused on with these exam past papers is solution concentration and stoichiometry. Okay, so we're going to talk about concentrations, uh, different ways in which we can actually measure concentration. Okay, we'll be looking at how to prepare solutions. We'll talk about the Dilution formula. I've put some questions on titration. So simply meaning the reaction between an acid, okay, and the base. And I've also put questions regarding solubility. Okay, so guys, please feel free. Okay, if you have any questions when I explain anything and you don't understand, please feel free to ask. Okay, so that you know. This time that you've joined the class should not be wasted. Okay, you should learn something from the class. So if I've explained anything and you don't understand, please tell me so that I try to explain it in a different way until you actually what? Understand it. Okay, so I've put together about 7 questions that are going to help us understand these concepts that you can see on the screen. Okay, so let's start with the first question here. So this question, okay, when it comes in the exam, it usually carries 3 marks. Okay, so the question is define the following concentration terms and give their units. Okay, define the following concentration terms and give their units. Okay, so the first one is percentage by mass or percent by mass. So what is percent by mass by definition? Okay, so I've written down the definitions there. So we'll be explaining them. Okay, so if you are holding your phone in portrait, put it in landscape so that the screen is big enough for you to see everything. Okay, so by definition, percent by mass, okay, this is simply the mass of solute divided by the total mass of the solution multiplied by 100. Okay, it's just the percent, so you're multiplying by 100. So now, remember that when making a solution, okay, when making a solution, you have to add or you need to have 2 things. You need to have the solute and then you have to have the solvent. So the solute is a solid. Okay, this one here is a solid that you are going to put in your solvent, which is what? A liquid. Okay, so the solvent is a liquid. So for example, if I get salt, which is sodium chloride, and then I put it in water. Okay, so when this salt dissolves in water, it's going to make a solution. We're going to call that as the salt solution. So now the percentage by mass is simply, okay, the fraction of the solution that is the solvent. I mean, that is the solute. So you're going to get the mass of the solute, okay? You put it on top there, and then you divide this mass of the solute by the mass of the solution, and then multiply by 100. That's what gives you percent by mass. So if, for example, the solute had mass 5, okay, and then the solvent also had mass 5, it means the mass of the solution is going to be 10. So now to find the percent by mass of this solute here, we're going to say mass of the solute divided by the mass of the solution multiplied by 100. Okay, so whatever percent we are going to get here, that's what we're going to say. That's the percent by mass of the what? Of the solute. So by definition, it's just whatever I've written there. I'm saying percent by mass. Okay, this is just simply the mass of the solute divided by the total mass of the solution multiplied by 100. Okay, and then that is the formula there I've given it. Okay, so this percent by mass doesn't have units. Okay, it's a percentage, so it doesn't have any units. Okay, or you can say it's a ratio. All right, the second one, so we've done this one. Let's do molarity. Okay, so there are 2 types of, I shouldn't say 2 types, okay, but there are 2 things that confuse our students. There's this one here, molarity. You've seen it here. So it's molar, and then there's R there. So it's molarity. There's R. And then there's this one here, which is molarity with the L. Okay, okay. It has the L there. So there's the one with the R and the one with the L. So these 2 things here, okay, they are both are used to measure concentration, but they are different. And we're going to see their difference today. Okay, so when you talk about molarity with the R there, That's the number of moles of solute per liter of the solution. Okay, the number of moles of solute per liter of the solution. So simply meaning I'm dividing the number of moles you can see in this formula divided by the volume of the solution that has to be in liters. Okay, so the units of the solute is moles. Okay, and then the units of the volume has to be liters always. Okay, so there are some questions where they'll give you the volume in milliliters, okay, or in any other units. So for you to find the molarity, you need to convert that volume to what? To liters, always. Okay, so that's the definition of molarity. Simply the number of moles per liter of a solution. And the formula is there. So the units are just going to be moles per liter, or you can write it as moles, okay, and then liter to the power minus 1. This here is the same as moles per liter. Okay, so those are the units there. And then molarity now with the L, okay? Molarity with the L is simply the number of moles of solute per kilogram of the solvent. So its formula, you can see it changes. It's the number of moles on top, and then down there, I'm going to have the mass of what? The solvent, and that mass should always be in what? Kgs or in kilograms. So the units for this is simply mole per kg. Okay, so another important aspect is to know the symbol. So if you're talking about molarity with the L, its symbol is a small letter m. If you're talking about molarity with the R, that is represented by a capital letter M. Okay, so in the questions, the way they are going to become, you have to be very careful. Okay, have they given you the capital letter? Then you know you are dealing with molarity there. Have they given you the smaller letter? Then you are dealing with what? Molarity there with the L. All right, so any questions there, guys, on what I've explained so far on these definitions? Any questions or clarifications? Okay, so if there are no questions, let's move on to part 2. Okay, let's move on to part 2. Part 2, okay, they're saying how would you make up a 1 liter, okay, of a 0.25 molar sodium sulfate. Okay, so here I think I made a typing error. So this one here has to be capital letter M here. Okay, I think even this guy here have to be capital letter M. Okay, so here they're saying how would you make up 1 liter of 0.25 molar sodium sulfate solution in water? Okay, so they want us to explain how we can make up a 1 liter of this concentration. Okay, so they're simply asking us, okay, they're simply asking us to find the mass, okay, of sodium sulfate that is required for this concentration here to be made. Okay, so I know that molarity, okay, is equals to the moles of solute divided by the volume, and this volume here should be in what? In liters. Okay, so here I've been given the molarity, the molarity there, which is 0.25 molar. Okay, I've also been given the volume, which is 1 liter. Okay, so how can I find the mass of this that will make up this concentration? I need first of all to find the moles. Okay, so I'll say cross multiply moles. Okay, we know the symbol for moles is just N is equals to molarity multiplied by the volume. So the molarity is 0.25 multiplied by the volume, which is 1. So it means the number of moles there are going to be simply 0.25 what? Moles. Okay, so now that I have the moles, I can easily find the mass. So remember, moles is equals to mass, okay, over molar mass. Remember? Okay, so I'm finding this mass here, so I can make it the subject. So it will be M is equals to N multiplied by the molar mass. So the moles are found 0.25 multiplied by what is the molar mass? Here we were told clearly that the molecular mass of this guy is this. Okay, so that's our molar mass. So I put 142.04. Then I multiply. So it means the mass of sodium sulfate that I'm going to find is going to be equals to 35.51 grams. Okay, so now that I've found the mass that is needed to make this concentration here, I'm going to answer this question here. So the question was saying, how would you make 1 liter of this guy here? Okay, so in your answering, you're going to say, to make 1 liter of 0.25 molar sodium sulfate, I'm going to dissolve, okay, 35, okay, I'm going to dissolve 35.5, okay, grams of sodium sulfate uh, in a volume of water, uh, in a 1 liter volume of water. Okay, that's what you're going to say. So that's how you would prepare that. Okay, you're just going to dissolve 35.5 grams of sodium sulfate in 1 liter of water. Then you make this concentration here. Okay, so any questions there? Okay, so I hope you guys are understanding. Let's look at part 2 there. Okay, so part B, they're saying how many milligrams of sodium sulfate would be weighed out to prepare 50 milliliters of 0.1 molar solution. So here again, we are finding the mass, but that mass, we should express it in milligrams. Okay, so I know that molarity is equals to moles over volume. So here I'll make moles the subject, so it will be molarity multiplied by the volume. So moles is equals to molarity multiplied by the volume is equals to, the molarity here is 0.1 multiplied by, and then this guy here is 500 milliliters, right? So remember I said the volume should always be expressed in what? Liters. So to change this milliliters to liters, you divide it by 1000. So like this. Okay, so 1000. All right, so when you do that and then you multiply with the 0.1, I'm going to get my moles as 0.5, okay, moles. Okay, so those are my moles there. All right, and then from here, oh, that should be 0.05, not 0.5. So 0.05 moles like this. So these are the moles here. And then from the moles, I can get the mass. So mass is equals to the moles multiplied by the molar mass. So the moles are 0.05. The molar mass was given here, which is 142.04. But they don't necessarily need to give you this mass here. You can simply find it from the periodic table. Okay, so if they don't put the mass, the molar mass there, don't say, oh, no, they didn't give me the molar mass. No, this molar mass, you can simply find it from the periodic table. So just do 2 multiplied by the molar mass of sodium plus the molar mass of sulfur plus 4 multiplied by the molar mass of oxygen. You're going to get this number here. Okay, so here they're just making it easy if they give you the mass. All right, so we can multiply these things here. What are we going to get? So the mass that I'm getting is 7.102, and this is grams. Okay, this is grams here. So the answer said how many milligrams? So I have to convert the grams to what? To milligrams. Okay, so uh, how do we convert the grams to the milligrams? Okay, so I know that 1 gram is equal to 1000 milligrams. So what about 7.102 grams? It will be equals to what? Okay, so you cross multiply. So it means X will just be equals to this number multiplied by this is going to give me 7,102 milligrams. So this is the number of the milligrams, okay? That should be weighed out to prepare 500 mils of 0.1 molar solution. All right, so any questions there? Okay, let's look at the next question, which is question number 3. Okay, so question number 3, it's very simple. We just have to understand what is going on. So question number 3, they're saying a solution is prepared by dissolving 1.26 grams of silver nitrate in 250 mils, okay, volumetric flask, and diluting it to the mark. Calculate the molarity of the silver nitrate solution. How many millimoles of silver nitrate were dissolved? Okay, very simple. So we are calculating the molarity there. So molarity is equals to the moles divided by the what? By the volume. Okay, so how do we find the moles? So the moles are simply equals to the mass over the molar mass. So here now they haven't given us the molar mass, so we have to find it. Okay, so the mass there is 1.26 grams. What about the molar mass? So we get it from here. So this is sulfur. I mean, this is silver. Okay, and then nitrogen, and then oxygen 3. So its molar mass will just be this guy, the molar mass of this plus the molar mass of nitrogen plus the molar mass of 3 times what? The oxygen there. So you just have to go to your periodic table here. So this is your periodic table here. So we are looking for, let me make the screen even bigger. So we are looking for the molar mass of silver nitrate like this. Okay, so silver, where are you? So where is Ag? So Ag is here. So you've seen the molar mass there down, it's 107.8682. But we always round these molar masses from the periodic table to 2 decimal places. So if I round it off there, it will be 107.87. And then plus the molar mass of nitrogen, which is this guy here. So that is 14.00674. Round it off to 2 decimal places. It's going to be 14.01. And then plus 3 multiplied by the molar mass of oxygen. So oxygen is 15.999. If I round it off to 2 decimal places, it's going to give me 16.00. So this is what you punch now on your calculator. So I have what now? Okay, I have 107.87 plus 14.01 plus 3 multiplied by 16. Okay, so that is going to give me 169.88 grams per mole. So this is my molar mass. So I come here and divide it by 168.88 grams. So what do I get here as my moles? So make sure you punch as well on your calculator. So this will be 0.007421 moles. Okay, so those are the moles. And then now we just have to find the volume in liters. So the volume has already been given there, which is volume is equals to 250 milliliters. So we said this thing should always be in liters. So I'm going to divide it by what? By 1,000 like that. And then this will be liters. Okay, so if I divide 250 divided by 1,000, I get 0.25 what? Liters. So this will be molarity is equals to, the moles is 0.007421 divided by the volume, which is 0.25 liters. This is moles. Okay, so when I divide this, what do I get? Okay, so I'm getting 0.029684. This will be moles per liter. Okay, so that is the molarity of the silver nitrate. Okay, that is the molarity of the silver nitrate. Okay, so if you have any question, please feel free to ask. Otherwise, we'll go to B. So on B, look at what they're asking us. They're saying how many millimoles of silver nitrate were dissolved. So these were the moles here. So how do we convert the moles to the millimoles? We know that 1 mole, okay, is equals to 1,000 millimoles. Okay, so I have now 0.07, I've forgotten 0.00741 moles. Okay, how many millimoles am I going to have? So you cross multiply, X will just be equals to this guy multiplied by 1,000 there. Okay, so that is going to give me what? So multiplying by 1,000 means I'm just moving this decimal place 3 times. So 1, 2, 3 times. So I get 7.421 millimoles. moles. Okay, so that is it for question 3. So any questions there, guys? Okay, so let's move to question 4. So question 4, they're saying sodium chloride, okay, with a mass of 2.92 grams was dissolved in water with a volume of 100 mils. Given that the molar mass of sodium chloride is this, okay, what is the concentration of sodium chloride in the solution? So the concentration there, we are finding the molarity. So it will be moles, okay, divided by the volume. And the volume has to be in liters. So we know that this moles is just the mass, 2.92 grams, divided by the molar mass, which is 58.44 grams per mole. Okay, and then this we're dividing with the volume. So the volume, this is 100. So 100 mils, we divide it by 1,000 like this to make it what? Liters. Okay, and then we can punch this now onto the calculator to get our molarity or our concentration. Okay, so my concentration, when I do this, okay, my concentration is simply, okay, my concentration is simply 0.500 moles per liter. Okay, so try to punch this on your calculator. You're going to find whatever I found there. Okay, so you said 2.92 divided by 58.44, and then say divided by, and then in the other brackets, you write 100 divided by 1,000 like that. Okay, you're going to get 0.49999. Okay, so I've just rounded it off here to 0.5 to make our calculations easier. Okay, so this is the concentration. Okay, and then now they're saying 10 mils of this solution here that has this concentration, okay, was removed and diluted to 250 mils with deionized water. What is the concentration of the new solution? So this one here, we are going to say this is our initial concentration. Okay, this is our initial concentration here. And then they said from the volume of this guy here, which had 100 mils, they just get 10 mils of it. So I'm going to say the concentration number 1 is equals to 0.5. Okay, this guy here. And then the volume 1 that I've gotten is 10 mils. Okay, and then now they're saying this solution was removed and diluted to this. So diluted to this means this is our volume 2. So our volume 2 is 250 milliliters. Okay, what is the new concentration, M2? Okay, so this calls for what? This calls for the dilution formula, which we said M1 V1 is equals to M2 V2. So I want to find M2. So I can just make it the subject. So I divide both sides by V2. It means I have M2 is equals to M1 V1 divided by V2. Okay, and we have all those things. So M1 is 0.5 multiplied by the 10 divided by the 250. 250. Okay, so what will be my new concentration, which is M2, if I do this? Okay, so that is 0.5 multiplied by 10 divided by 250. I get my concentration 2 as 0.2 molar. Okay, so any questions there on how we've solved B? Okay, we look at C. So C, they're saying, okay, C, they're saying if you wanted 0.2 moles. Oh, someone has a question. Mr. Bennett, you can ask.
Yes, sir. Why are not converting 250 milliliter to liters?
Okay, yeah. So when remember I said you should always convert the volume to liters, right? So there's
Yes.
an exception when you are using the dilution formula. Why? Because the volume on top here, okay, is going to have milliliters, right? And then even this volume down is going to have milliliters. So these things here are going to cancel. Okay, so they cancel out. So it doesn't matter if you don't convert them to the milliliters. But if I mean to the liters, if you want, you can convert to liters. It will still give you the same ones.
Okay, thank you, sir.
Yes. So only when you are dealing with the dilution formula, this formula here, then you are at liberty to not convert the volumes. Okay, as long as they are in the same units like this. Okay, you can just cancel them out. But if it's not the dilution formula, you are just finding the concentration, always make sure that the volume has been changed into liters. All right, so now let's solve part C. So part C, they're saying if you wanted 0.2 moles of sodium chloride, what volume of the solution would you need? Okay, so here they've given us the moles to be 0.20 moles. Okay, we know the initial concentration that we found there was 0.5 moles per liter. So now they want us to find the volume. Okay, so from this formula here, we're just going to make volume the subject. Okay, so it is molarity is equals to moles over volume. So cross multiply, you get molarity volume is equals to moles. So I divide both sides by the molarity. So it means volume will just be equals to the moles over the molarity. So now we have those values. So the N is 0.2 moles. And then the molarity there is 0.5 moles per liter. So the moles and the moles cancels out. I just remain with the liter. So that would be 0.2 divided by 0.5. I get 0.4. And this will be what? Milliliters. Okay. This will be, no, that will be liters. Okay. That will be liters because here I remained with the liters. So 0.4 liters, that was I get. If I convert these liters to milliliters, it's going to be 400 milliliters. All right, so any questions there, guys? Okay, so if there are no questions, let's look at question 5. So question 5, it's a similar thing to what we are just from doing. They're saying benzoic acid, which has this mass, was dissolved in ethanol with this volume. The molecular mass or the molar mass of benzoic acid is given there. What is the molar concentration of this? So we're finding the molarity is equals to the moles, okay, divided by the what? By the volume. So the moles is the mass, 24.5 grams, divided by the molar mass, 122.12 grams per mole, then divided by the volume, which is 100 milliliters. Okay, I have to divide it by what? By 1,000 to change it into liters. Okay, so you punch this directly onto your calculator. I'm finding 2.006 moles per liter. Okay, so that is the molar concentration there. Okay, so just punch whatever is on top there on your calculator. You're going to find it. Okay, so this was part A. And then part B, they're saying what volume of a solution would contain 0.5 moles of benzoic acid. Okay, again, they've given us the moles, we have the concentration, we just want to find the volume. So from the previous question, we said volume is equals to the moles over the molarity. So the moles is 0.5 moles divided by the concentration here, which is 2.006 moles per liter. So the moles and the moles cancels out, I only remain with the liter. So 0.5 divided by 2.006, I get 0.2493 liters. Okay, so that's the volume. If you want, you can convert it to milliliters by multiplying this by 1,000. You're going to get 249.3 milliliters. Okay, so that's the answer there. Any questions? Okay, let's pause a bit for the solving. We just look at a conceptual question now. So question 6, I put the question which says, discuss 3 factors that influence the solubility of a gas or a solid or a liquid. Okay, so the most important factors that affect the solubility of either a gas, um, a, a solid, or a liquid. One, it's temperature. Okay. Two, it's pressure. Three, it's the nature of the solute, or the nature of the solvent. Okay, or the nature of the gas. So those are the most three important things that influence the solubility of a gas, solid, or liquid. Okay, so you can take a screenshot of this. Make sure you go through the points there. Okay, I explained whatever I was explaining there. Okay, but here I'm just going to say some few things. So for most solids, okay, uh, in liquids, solubility increases with the temperature. Okay, why? Because as the temperature increases, the kinetic energy of the particles, okay, increase, and they tend to break the solute to solute interactions, allowing the solute to dissolve more. Okay, so for example, the solubility of potassium nitrate in water, it increases strongly with temperature. So if we're at a very low temperature, the solubility will just be normal. But immediate as you are increasing the temperature of the solvent, which is water, you're going to see that the solubility of that potassium nitrate is going to increase rapidly. Okay, right. Um, that's for the temperature. Okay, and then for pressure, pressure follows what we call as Henry's law. Okay, so the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas above the liquid. Okay, so this means that if you increase the pressure, okay, or increasing the pressure increases the amount of gas that dissolves. That's what it means. Okay, so for example, when you take carbon dioxide, okay, carbon dioxide is more soluble in soda at a high pressure, okay, which is why the soda fizzes when the pressure is released. So when you buy those energy drinks, okay, the carbon dioxide, okay, is present in that drink. Okay, it's present in that drink. So it's only soluble in that drink at a very high pressure. So meaning when the bottle is closed. So immediately you open the bottle, okay, the pressure in that bottle decreases. So when the pressure decreases, the carbon dioxide can no longer be soluble in that drink. No wonder you hear that caps when you open the drinks. Okay, so yeah, so that's about pressure, and then the nature of the solute or even the nature of the solvent. Okay, so when you talk about the solvent, it will depend if the solvent is polar or it's not polar. So if the solvent is polar, then the solute um, is going to dissolve very well. Okay, but for non-polar solvents, it's going to be hard to dissolve. Okay, so for example, if you get sodium chloride, okay, sodium chloride is ionic in nature, right? We know it's going to separate into the sodium ions, the chloride ions. Okay, so if you put it in water, it's going to dissolve very fast because water is a polar solvent. Okay, but when you put it in a solvent like hexane or even ethanol, okay, the solubility there is going to decrease because those solvents are non-polar. Okay, they are non-polar. All right, and then even just the nature of the solvent, depending on the density. So, for example, if you get oil, okay, you pour it in water, it's not going to dissolve in water. Okay, there will be no homogeneous mixing of this oil and water. Oil will just remain on top. Okay, because it has a lesser density than the water, so it won't dissolve. Okay, so by the nature of the solvent having a smaller density than the water, it won't dissolve in that what solvent. All right. Anyway, you can read through this to understand. Okay, and then next we look at the last question. So the last question is on a titration reaction. So meaning there's uh, some sort of a salt, an acid and a base. Okay, so let's look at question 7. Again, it's very simple. If you have questions, please ask. So here they're saying in a titration experiment, a student finds that, okay, 23.5 mils of sodium hydroxide solution are needed to neutralize 0.55 grams of KHP. So what is KHP? Okay, so KHP is what we call as potassium hydrogen phthalate. Okay, potassium hydrogen phthalate. So the question is, calculate the concentration in molarity of the sodium hydroxide in the solution. Okay, so first of all, here we need to write the equation, okay, in which the sodium hydroxide is going to be um, reacting with the potassium hydrogen phthalate. Okay, so the potassium hydrogen phthalate, it's K, H, and then P. So here in the equation, they want us to calculate the molarity of this sodium hydroxide solution, this guy here. Okay, that's what they want us to calculate. So how are we going to calculate this when we have just been given the volume? Okay, remember, to calculate the molarity, we need the moles, okay, and then divided by the volume in liters. Okay, so meaning that where are we going to get these moles here for the sodium hydroxide? We're going to get it from uh, the molar ratio of this potassium hydrogen phthalate with the sodium hydroxide. Okay, so the reaction is that potassium hydrogen phthalate, which acts as an acid, okay, plus sodium hydroxide. This here gives it gives potassium nitrogen phthalate. I mean potassium sodium phthalate plus water. Okay, because this is an acid, this is a base. So you're always going to produce a salt here and the water there. Okay, so to find the moles of this guy, we are going to use the moles of this guy and then we get the mole ratio. So I'm going to say moles of potassium hydrogen phthalate is going to be equals to the mass, because we've been given its mass there, grams, divided by the what? By the molar mass. Okay, so now the molar mass of this guy here, you can look it up on the internet. Okay, the molar mass of potassium hydrogen phthalate is simply 204.22 grams, or you can simply add the molar masses of this. You're going to get this per mole. Okay, so I'm going to divide by that. So 204.22 grams per mole. So this is going to be equals to, so when I divide this, what moles am I going to get? Okay, when I divide this, what moles am I going to get? I'm finding 0.0026936 moles. So make sure you counter check with your calculator to see if you're finding the same moles there. So these are the moles for potassium hydrogen phthalate. Okay, and then when we look at this equation here, is it balanced? Okay, so here I have 1K, 1K. H, I have 1, 2, even here I have 2H. And then P, I have 1, even here I have 1. Oxygen, I have 1, even here I have 1. Nitrogen, sodium, I have 1, even here I have 1. So the equation is balanced. So what is the mole ratio of the potassium hydrogen phthalate with the sodium hydroxide? The mole ratio there is 1 to 1. So the mole ratio of 1 to 1 simply means the moles of this are exactly the moles of this. So these ones here are the moles of potassium hydrogen phthalate. But because the mole ratio here is 1 to 1, even these guys here are going to have the same moles. Okay, so I'm going to erase this now, and then I'm going to say moles of sodium hydroxide are going to be equal to the moles of potassium hydrogen phthalate, because the mole ratio there I found it was 1 to 1, which is equals to 0.0026936 moles. Okay, so now I have the moles of sodium hydroxide, and then the volume was given there. So meaning the molarity will just be equals to, okay, the moles divided by the volume. So now this volume has to be changed into liters. So that would be 23.5 divided by what? 1,000, like this. Okay, so this is going to give me what? So you punch it on your calculator. Okay, so my molarity there will simply be 0.11463 moles per liter. Okay, so that is the molarity of the sodium hydrogen solution. Right. So any questions there, guys? Any questions on how we've done that?
Sir,
Yes, yes.
um, so apart from using the equation, do we have the formula for molarity?
For molarity, the formula.
Yes, sir.
Yes, we have. So molarity, we said it's equals to the moles over the volume. This is the formula of molarity. Unless you are asking for something else.
Okay, sir. No, I'm clear.
Oh, all right. Right. So any other questions, guys? This was our last question. Okay, so if there are no further questions, I think we end here. Okay, so I think this was the last free class. Okay, so Mr. Bernard, you have a question?
Yes, sir.
Yes, you
I
can
would
ask.
like you to repeat on more ratios. Suppose we have 1 to 2. How would you uh, compare that ratios?
Okay, so let me do it here. So for example, remember the equation that we had, right? So the equation that we had was the potassium hydrogen phthalate plus sodium hydroxide, and then you are producing potassium, sodium phthalate, and then plus the water there. And then here the mole ratio is 1 to 1. But what if the mole ratio is 2 to 1? So let's say here we had a 2 like this. Okay. So let's say on the potassium hydrogen phthalate we had a 2 there. Then the mole ratio is going to be, we're going to say 2 to 1. Okay. So this one here is the potassium hydrogen phthalate. This one is the sodium hydroxide like this. So now remember that we found the moles of this potassium hydrogen phthalate to be, we had found to 0.0026936 moles, right? Remember? So you're just going to put it under the 2 here. So 0.0026936 moles. And then this, you're going to say to x because you don't know it. And then you are going to cross multiply these two. So 2 multiplied by x, I get 2x. This multiplied by 1, I get the same thing. Okay, and then you divide by 2, divide by 2. Whatever answer you're going to get here, those will be the moles for the what? For the sodium hydroxide. So that's how we would handle a ratio which is 2 to 1 or 1 to 2. You would do a similar thing here. Is that clear?
Yes, sir.
All right. So I think we've come to the end of this lesson. Thank you so much for watching. For those who want to subscribe with us, okay, we have a website, okay, full of videos that can help you. Okay, so we have tutorial sheets, we have past papers, we have topic lessons. So you can just go on Google, okay, Chrome, and then you search Discrete Learning Institute. So this website is going to come here. So if you don't have an account, create an account, okay, and then you log in, you subscribe for the course of your choice. Okay, so for example, if you subscribe for chemistry, maybe, okay, you're going to find 2 folders there. You go in general chemistry, that's for first year. So you go in this general chemistry folder, and then you're going to find topic lessons, summarize notes here, tutorial sheets, past quiz, test and exam papers, lab report, samples. You can access everything. So whatever topic you're going to learn in chemistry, there's already a video available here and also notes. Okay, so here there are videos and notes for all the topics that you're going to do in chemistry. Here they're summarized, handwritten notes, very, very nice notes. You can check them out when you subscribe. Then here there are tutorial sheets and assignments. So let me show you this folder for the tutorial sheets and the assignment. So when you go here, depending on the whatever university you are at, okay. So for example, if you are maybe at CBU, okay, we go to CBU there. You're going to find video solutions, written solutions. So if you go in video solutions here, you're going to find you're going to find the tutorial sheet. So you can see there are a lot of tutorial sheet videos here. So tutorial sheet on stoichiometry, or whatever topic that you can think of, organic chemistry, chemical equilibrium. They have videos, a lot of them. Okay, scientific notation. So whatever you want to learn, you can access it here and learn at your own time, at your own pace, even when you're in your in your blankets. And then also we have a mobile app. So that mobile app is on Play Store. Okay, so you go on Play Store, you search for Discrete Learning Institute. Okay, the app is going to come, and then on that app, you can even be able to download the videos. Okay, so you download the videos to watch them offline. So you don't always have to need bundles in order to learn using our platform. So you can download the videos in advance. And in advance, maybe you go to a place where there's Wi-Fi, you download the videos that you want, and then even without internet, you'll still be able to access them. Right. So yeah, so make sure you register for the lessons. This was the last free class. Bye bye. Thank you so much.